Hello students, welcome to Math 1100 College Algebra. But before starting College Algebra, let's spend some time on preliminaries. This is going to be a review, so I'll be brief. The first topic is sets and numbers, and please remind yourself about the set notation. List of elements or set builder notation where you have a certain condition that could be a bit verbose in there. And elements and subsets, we use these kind of notations. Please remind yourselves. Next, algebra of sets. A union is basically A or B, and that encompasses both A and B together. And it's a little bit strange because I use the term both A and B together, but the proper name should be A or B. But I'm afraid that's the way mathematics was built. It does not go hand in hand perfectly with English language. You just have to live with it. This is A or B. Next, A and B. And A and B is not both A and B put together. You see, A and B is only the intersection part, the middle part only. Again, forgive me, I did not create these kind of words. Those have been, well, they have been created long before I was born, so I'm not really responsible. Nonetheless, it's confusing. So this is or, A or B. This is A and B, only the middle part. Or is big and is small. Next, not A, or all except A, and that one's easy to understand. And then the other two are not that important. A not but B. B but not A. Okay, easy to understand, and they're rarely used. Next, let's talk about sets of numbers, and we use this double struct font. N for natural numbers, W for whole numbers, Z for integers, Q for rational numbers, R for real numbers, C for complex numbers. Okay, finally, intervals. Intervals are part of real numbers, and it must start with some real number A and end a certain real number B. And if both A and B are included in this set, less than or equal, then we use bracket. Now, if both of them are off, we have strictly inequality. In that case, we use parentheses. Now, if one is in and the other is out, in part is bracket, and out part is parentheses, and vice versa. Okay, so much for interval notations. Let's move on. Okay, next, some property of real numbers, some algebraic properties. The properties related to algebraic operations, addition and multiplication. Is everything okay to you? Is there anyone who is not totally comfortable with any of these rules? I hope not. Okay, all right. Inequality property, or some people call it ordering property, because it gives you an order of real numbers, smaller numbers to the left and then bigger numbers to the right. First, we have to have this trichotomy. If you have two real numbers, A and B, either A is less or A is greater, or A and B have to be the same. One and only one of those three must hold. That's why it's called trichotomy. And that allows us to arrange all the real numbers along a number line. Smaller numbers to the left, bigger numbers to the right. Transitivity, that's easy. A is less than B, B is less than C. Then, of course, A is less than C. Preserving the addition, if you add same number to both left-hand side and right-hand side of the inequality, we have the same inequality. Same goes for multiplying a positive number. But if you multiply a negative number, that's a little bit different story. I hope everybody remembers. Multiply a negative number, then you have to flip the order of the inequality. I mean, that's what I'm talking about. Let's see, what if I multiply by a negative number? Then you'll have to flip the order of the inequality. I hope everybody remembers. Finally, completeness property. The set of real numbers completely fills up the number line. Consequently, we can associate coordinates and all kind of real number arithmetic with geometry. This allows us to consider coordinate planes and the graphs of functions, and we can consider lines and circles and so on and so forth. Okay, going good. Let's go to the next topic here. What about subtraction and division? There's no distinction between addition and subtraction. It's just adding a negative number. Same goes for division, just multiplying the reciprocal. But there's of course a bit of catch here. Here, b should not be 0. The denominator should not be 0. Otherwise, pretty simple. Properties of 0, okay, adding 0 doesn't change anything. Multiplying 0, everything will become 0. Here's an interesting property here, zero product property. If you multiply two numbers and the result is 0, then one of them has to be 0, maybe both of them. X times y is 0, then either x is 0 or y is 0. X times y times z is 0, then either x is 0 or y is 0 or z equals to 0. One of them has to be 0 or maybe more than one of them. In any case, there's no way you're going to get 0 by multiplying non-zero numbers, no matter how many times. This is going to be useful. Division property, 0 divided by x is always 0. That's easy to see because that's the same as multiplying 0 times 1 over x, and you see it's basically this property here with different character. Yeah, multiplying by 0, you're going to get 0. But this one's different. X over 0 is undefined. Denominator cannot be 0. No problem there. Let's move on. Properties of 1. Multiplying by 1, no change. And if you divide by the same thing, then you're going to get 1. Of course, you cannot divide by 0, so there's a bit of a catch. 0 over 0 is undefined, not equal to 1. Finally, properties of sign. Well, I hope everybody remembers. Positive times negative is negative. Negative times positive is negative. Negative times negative is positive. Alright, negative times negative is positive. Double negative is positive, and so on. Similar things for division as well. I hope no problem there. Alright, the trivial part is done, and in the next video we're going to talk about some a little bit harder properties. Algebra essentials and geometry essentials. See you soon.